We're going to keep working with some application problems. This is section 1.7 for college algebra. And we're going to look at geometry type of problems. So in geometry type of problems, a lot of times you're working with rectangles of some sort, kind of the paper folding into a box is a type of geometry application. This one we have a garden that's this gardener has 46 feet of fencing, and they're going to enclose a rectangular garden that has a border that is 2 feet wide surrounding it. So here's our picture. If the length of the garden is to be twice the width, then we're supposed to be figuring out what's the dimension of the garden. So the length of the garden is to be twice its width. So let's label the width of the garden, and then the length would be twice the width. And we're supposed to figure out what's the dimensions of the garden. Well, the gardener has that 46 feet of fencing. So this is actually the fencing that the gardener has 46 feet of. So the perimeter of fencing is 46 feet. But we're given 2W and W from in like the perimeter of the garden, not the perimeter of the fence. So if we think about that, the width of the fence would be right here. And then we've got that border going around the garden that they told us is 2 feet wide all the way around. So we've got 2 feet of border. So this is 2 feet and this is 2 feet. And then on the length of the fence, this length here is 2W. And then we've got our border of 2 feet here and of 2 feet here. So when we look at the fence perimeter, we've got to go all the way around. So we have to go this side here, which is going to be W plus 2. And then the length of the fence perimeter would be 2W plus 4. And then we have another width over here and another length. So the perimeter for the fence, we've got, I gave you a couple formulas up here. Area of a rectangle, length times width. Perimeter of a rectangle, 2 lengths plus 2 widths. So for our fence, we have 46 feet would be 2 of our lengths, so 2 times 2W plus 4, plus 2 of our widths, 2 times W plus 2. And then we'd be able to solve for W. And remember that when we started setting this up, W was the width of the garden. Okay. So we can pretty easily solve this equation. We'll go ahead and distribute the 2 here and the 2 here. So now we've got 46 equals 4W plus 8, and then 2W plus 4. Combine our like terms. So we've got 4W and 2W, and then 8 and 4. So 46 would equal 6W plus 12. Oh, did I write that down wrong? I sure did. Way back here, you guys. That was W plus 4. I know you were probably all thinking it and fixing it in your head, so I appreciate that. If you were here with me, you would have fixed it in person, but you're not, so we'll fix it here. So 6W plus 16, and then subtract the 16. So we get 30 equals 6W, so then W would be 5. The original question in part A, this is part A, was what will be the dimensions of the garden? So the garden will be, or what are we in feet? So 5 feet wide by, the length was twice that, So 5 feet by 10 feet. Okay, part B, what is the area of the garden? Well, that's going to be pretty easy to do after we just found the dimensions. Area of a rectangle is length times width. So the area will be 5 times 10. So area is 50, and that's in square feet for area. And then what does part C want? Part C, if the length and width are to be the same, what will the dimensions of the garden be? So I don't think we'll finish this one. We'll just set it up. So now instead of my length and width, my length being twice my width, now my length is going to be the same as my width. So if I draw a little picture here, my length and width are the same now. And then I still have that 2 feet of fencing, or that 2 foot of border around my fence. So here's W, 2, 2. So now the length and the width are going to be the same, right? Because we just set that up. So this side, the length side and the width side will both be W plus 4. And I still have 46 feet of fence. So now instead of this formula up here, we'll have 46 equals. We could set it up like 2 length plus 2 width, or we could set it up like all 4 sides are the same. Either way, we'll get the same equation at the end. So if we do 2 times W plus 4 plus 2 times W plus 4, or if we do 4 times W plus 4, since all 4 sides are the same. Either way, we would get the same equation in the end. So we would just go through and solve that like we did the other one. And I'll just ... because I don't think you need me to go through those steps again. The next type of problem we have are mixture problems. And those are going to have a variety of applications. Mixtures. Mixture problems are going to use 2 equations. So we're going to actually have a system of equations that we will solve either by elimination or substitution. So we'll get to look at those a little bit. I'm going to talk about a money type of mixture and a concentration type. And then we're actually going to go back and look at a previous problem and change our type of setup that we used. So in a money type of problem, like we're mixing different types of coffee or different like trail mix, or, like raisins and peanuts, or expensive chocolate and cheap chocolate, whatever we're mixing together, or like pounds of oranges and pounds of grapes, whatever it might be. We're going to have one equation that's going to account for the total weight of the mixture, and then one equation that's going to account for the total cost of the mixture. And when we're working with the cost, it will be like cost per pound times number of pounds. And then we're going to have a different type that is a concentration, like chemistry problems. So one of our equations is going to have to do with the total volume that we have. The other is going to be the amount of solute. That's what's dissolved in it. And we're going to take, for that one, for the amount of solute, we're going to use the percent concentration times the volume of liquid to get the amount of solute. So this coffee manufacturer wants to market a new blend of coffee that sells for $3.90 a pound by mixing 2 coffees that sell for $2.75 and $5 per pound, respectively. What amounts of each coffee should be blended to obtain the desired mixture? Assume the total weight of the desired blend is to be 100 pounds. So sometimes they'll tell you how much you're going to mix of each type, and sometimes they don't, as you can see here. But each time that you have one of these problems, it's set up slightly differently. Like they might tell you they want the final amount of money to be a certain amount, and then you would have to take the final weight times the cost per pound of the mixture. Anyway, you're going to see lots of varieties of this, but we're going to basically set them all up the same way. So we've got a blend of coffee that's going to sell for $3.90 per pound. And we're going to have 100 pounds of it. So when we figure out the total worth of that blend, we would multiply $3.90 times 100 pounds. So we have a $390 value for our blend. And we're doing that by mixing one type of coffee that doesn't really give us a name. So the first type of coffee is going to sell for $2.75 per pound. And they don't tell us how much of it we have. The second type sells for $5 per pound. So let's just say we're going to use X for the amount of first type of coffee. Then how much is its value going to be? If we take the cost per pound times the amount we use, is going to be 275x for the value of the coffee. And then the $5 per pound coffee, we don't know that either. So we'll do Y for the amount of the second type of coffee. And then its value, we take the cost per pound times the amount we're using, and that would be our value. Okay. So our two equations for these mixtures, we're going to have one that has to do with the total weight and one that has to do with the total cost or value of the mixture. So here we've got our two equations. Here's our weight equation. We have 100 pounds in the blend. We're mixing the first type and the second type. So that first equation is going to be 100 pounds for the total weight of the mixture. And the way we're getting that is by adding the two blends, X plus Y. So X plus Y equals 100 is going to be our weight equation, the weight of the mixture. And then the value equation is going to be like how much money we're spending. So we would take the cost per pound times the number of pounds. So 2.75x. And then we're going to add the second mixture, cost per pound times number of pounds. So 5y. And then we're going to take the blend altogether, cost per pound times number of pounds. So those are our two equations. And we would solve these either by substitution or elimination. I might go ahead and simplify this one. So that's the $390. So X plus Y equals 100, 2.75X plus 5Y equals 390. So those are our two equations. Now, if we're going to solve by substitution, solving by substitution means we would need to get one of the equations rewritten so that it says X equals or Y equals, and then we plug that into the other equation. So if I take equation 1 and I subtract like Y from both sides, I'll have X equals 100 minus Y. I am then going to sub that into equation 2. So I'm replacing X with 100 minus Y. So here where I have X, I'll replace that with 100 minus Y. So that will be 2.75 times 100 minus Y plus 5Y equals 390. Then I would distribute that to 0.75. So 275 minus 2.75y plus 5y equals 390. Combine like terms here, that gives me 2.25y. Subtract the 275 over, that gives me 115, I want to say. I better get a calculator. I don't want to have a mistake. Okay. 390 minus 275, 115, yeah. And then divide both sides by 225, 2.25. So 51.1 repeating. So y equals 51.1 repeating. Normally then they'll tell us like what to round to. So once I know what y is, I can get what x is by subbing that back into like this equation here. So then x would equal 100 minus 51.1 repeating. So 100 minus that. And x would equal 48.8 repeating. So whatever they want us to round to, then we would say we should use 48.9 pounds of the $2.75 coffee and 51.1 pounds of the $5 coffee. So that is if we're solving by substitution. If we're solving by elimination, what we want to do is multiply one or both equations by some constant value, some constant number that would make one of these variables like add up to 0 when I combine the two equations. So if I like take equation number 1 and I multiply it by negative 2.75, then that's going to give me negative 2.75x minus 2.75y equals negative 275. Then I'm going to add that to equation 2 without doing anything to equation 2, which will give me 2.75x plus 5y equals 390. Now, when I add those two equations together, you're going to see that the x's add to 0, the y's give me 2.25y, and on this side equals 115. Notice that that is the exact same thing that we got by using the substitution method. So when I divide both sides by 2.25, I get 51.1. Then I sub that into either equation 1 or 2. I'll use equation 1, and then I will get x equals 48.8. So whichever method you use to solve, you should get the same answer. And then we would know that we should use the 51.1 pounds of the $5 coffee and 48.9 pounds of the $2.75 coffee. All right. The next type of mixture problem we're going to look at is chemistry. So in a chemistry type problem, we're going to have still two equations. One's going to have with total volume, one's going to have with the amount of solute. So here we've got how much water must be evaporated from 32 ounces of a 4% salt solution to make a 6% salt solution. So our total volume, see, we have a salt solution and water. We've got 32 ounces of 4% salt solution, and we're mixing it with water, or we're letting water evaporate. Water is evaporating, and we want to end up with a 6% solution at the end. So How much water must be evaporated from 32 ounces of 4% salt solution? So with our total volume, we have 32 ounces we're starting with. So here's going to be our volume equation. I'm going to show you two ways to set this up. 32 ounce salt solution, and we're evaporating water. So we'll go minus W. So we'll say W equals amount of water evaporated. And then we want to end up with a 6% salt solution. So that's another thing we don't know is how much we're going to end up with our solution. So let's say S might be the amount of solution that we have at the end. So 32 minus W equals S, or the final volume, however you want to set that up. And then our other equation is going to have to do with the amount of solute. And that's the one where we're going to take percent times volume, and then percent times volume, and percent times volume. So our percent times volume of our 32 ounces of 4% salt solution will be percent, which will be 0.04, times volume of 32. Now, since we're evaporating water, we want to subtract the percent concentration of water is going to be 0%. So we're going to take 0 for our percent times W for our volume. And then at the end, we want to end up with 6% solution. So 0.06 times the volume, which was our other variable of S. So then here's our system of equations. If we clean it up a little bit, 32 minus W equals S. And then 0.04 times 32, make my calculator again, 0.04 times 32 is 1.28. And then that makes 0, so 1.28 equals 0.06 S. Now this system of equations is very easy to solve because we can immediately solve for S here and get 1.28 divided by 0.06, 21.3 repeating for S. And then we can substitute that into equation 1. So 32 minus W equals 21.3. Subtract 32 from both sides. Negative W equals negative 10.6 repeating. So W would be 10.6 repeating. So when we answer the question, how much water has to be evaporated, we would say that we should evaporate 10.7 ounces of water. Now, another way to look at this problem is sometimes I just draw like different containers. I guess I should use my same colors I used. So if I start with my 32 ounces of 4% solution, I would draw my little beaker here. And I have 32 ounces here. So 32 ounces, and it's 4% salt. And I'm evaporating some amount of water. So I've got my other beaker that I'm going to let evaporate, so I'm subtracting a certain amount of water that is 0% salt. And I don't know how much water, so I'll use W. And then I want to end up with, at the end, a 6% solution, 6% salt. And I don't know how much I'm going to end up with, so I could either use a variable here, or I could say that the amount I'm going to end up with is 32 minus W, since I have 32 ounces to start with, and I'm subtracting water to get that salt. So then if I write my equation for the amount of solute, or the amount of salt I have, I would take the percent concentrate times the volume, and then either add or subtract, depending on if I'm mixing two solutions together or letting evaporate, percent times volume of my second, and then equals percent times volume of my final. Or if they tell me at the end I want to end up with 7 grams of salt, then we would just use 7 grams. But in this case, we do percent times volume. So we would take percent 0.04 times volume 32. Since we're evaporating, we'll say minus 0 times W. And then at the end, we want to end up with 6% times 32 minus W. So in this case, we only have one variable and one equation, but we'll still get the same solution when we're done. 0.04 times 32, we saw that up on the other part of it was 1.28. This ends up being 0, so equals 0.06 times 32, I don't know that one, 0.06 times 32, 1.92, minus 0.06 W, and then 1.28 minus 1.92 is negative 0.64 equals negative 0.06 W. Divided by the 0.06 on both sides, we get 10.6 repeating. So we're still going to get that same solution to that problem. If we go back to our page about interest, so that was a previous video. So if you are watching this out of order, you won't have these notes. But if we look at this interest problem as a mixture, where we're mixing interest that pays 15% with interest that pays 7%, so we'll kind of use our same variables that we had before, then we're going to have one formula that's going to represent the amount of money invested and one formula that's going to represent the amount of interest earned. So we could set this up as a mixture problem. And when we do that, we're going to have one equation that will be total money invested, and the other equation will be total interest, whether it's earned or paid. So when we do that with this particular problem, the total amount we had invested, we were investing in B bonds and CDs, and we had $50,000 total. So our first equation for total money invested, we would have the amount we invest in B bonds plus, I'm going to say C is the amount we invest in CDs, would equal 50,000. And then for interest, we'll take the percent times money, percent times money, percent times money. So here in B bonds, it was paying 15%. So we have 0.15 B. In CDs, it was paying 7%. So 0.07 C. And then at the end, it doesn't tell us a percent she wants to earn. It tells us like an exact amount. So she wants to earn $6,000. So their total interest will be $6,000. Now, if we were going to solve this by substitution, we could subtract that C from both sides or subtract the B from both sides, whichever way you want to go. And we would have an equation. Let me see if I can get the light turned on here without getting up. Nope, can't. Come on, light. There we go. So we would have 50,000 minus B for our CDs, and then we would plug that in here, which is exactly what we had up here. So we would have had 6,000, there's our 6,000, equals 0.15 B plus 0.07 times 50,000 minus B. Or we could solve by elimination. So like multiply this whole equation 1 by negative 0.07 and solve by elimination.